What are you smiling at? All right. Okay, here we go. Chapter 7 review. This is a great chapter. This is the last chapter. We have our exam coming up, last exam before finals. So I just want to go over just some, there's only like 3 main points, and then we're going to do some examples, and we're going to be done. Okay, so this will be a good review for you. So in 7.1, we talked about what is a linear system. So just a reminder, a linear system is 2 linear equations. Now there could be more than 2, but we only deal with 2 in this class. 2 linear equations, okay, and that is a system. And it is solved when a set of ordered pairs, so that is like a point or an x equals and a y equals, satisfies both equations. Okay? Now we've talked about satisfies both equations before, but that means that when you plug the x value and the y value into both equations, it makes both equations true. And I'm going to show you some examples in a second. Okay? So substituting the x and the y values into the 2 equations makes both of the equalities true. So here below, here are some examples. Okay, so there's a positive example here, and then I'm going to show you 2 non-examples because I think that might really help you understand. So let's say the system we have is x plus y equals 7 and 4x minus y equals 8. Okay, that's our sample system. So the solution to this system is x equals 3, and we're not going to go over how we solve that right now, but the solution is x equals 3 and y equals 4. That makes both equations true, okay? And graphically, the way you see this is that this point 3, 4 is a point that is at the intersection of those lines, okay? So if you plug 3 in for x, and I'll do it down below here, 3 in for x and 4 in for y, that makes a true statement, okay? And for the second one, 4 times 3 minus 4 is 8. That's 12 minus 4 equals 8. That's also true. All right? So a solution to a system of 2 equations, if the solution exists, then it is the intersection point, and it's the values of x and y of that point. And when you check, it makes both equations true. Okay? Now, I really thought that some non-examples would help. So let's say we have a solution of, a proposed solution of x equals 3 and y equals 5. Well, if x equals 3, 3 plus y equals 5, that does not equal 7. You see that? So that's not true. So we know right away this is not a solution to the system. Does it work on the other one? Well, we don't even really have to check. We know it's not true. But 4 times 3 is 12 minus 5. That does not equal 8 either. And so graphically, this is what it would look like. It would look like a point up here. You see? Oh, can we see that? Hello. Okay. The point up there, that's not on the line. It's not on either line because it's not true for either statement. You see that? I'm going to try and just zoom in so the back can see that. But this is the point. This is the point 3, 5. It's not on either line. Yeah. Okay. What about the points 5, 2? Okay, 5, 2. Well, if we check 5 plus 2, oh, that does equal 7. So let's check the other one. 4 times 5 is 20 minus 2. Uh-oh, that does not equal 8. It equals 18, right? So it doesn't equal this one. So what that means is it's on one line, but not on the other. And it would look like this, about this, 5, 2. See? So when you visualize this, a solution is the point that's on both lines. It's the intersection point. Okay? A point that does not satisfy either or that does not satisfy both is not a solution. Any questions? We're good? All right. Okay, what's the next main point? Multiplying or dividing equations in a linear system by a non-zero number or adding or subtracting the equations produces an equivalent system. Okay, so this is important when we do elimination, right? So we did elimination. So think about this. Actually, just give me 1 second. I thought I had a link somewhere here. Where did that link go? Oh, my bad. Oh, here it is. Here it is. Okay. So let's just take a look at this, okay? So let's say we have a line, x minus y equals 2. All right? If you multiply this equation by 2, you get an equivalent line. You get the same line, but just looks a little different. See, this is 2x now minus 2y equals 4. If you multiply everything by a constant, even if it's another constant like 3x minus 3y equals 6, these are all the same, all right? And I want to show you this on Desmos, that it's all the same. If I can just do this, I think I'll have to copy this link. Give me a second. All right, so here's Desmos. I'm going to show you this is true. So let me just show you. I've got x minus y equals 2. That's the one in our example, and that's this blue line right here. Okay. Now I've also got set up x minus y equals 2, but I've put coefficients in front of each of those. All right. So if I have the blue line off and the red line on, you see they're the same. Okay, because everything is 1. A, B, and C are 1. So what happens if I move B to 2, right? We multiplied everything by 2. So if I move B to 2, this is what happens. Then if I move A to 2, that's what happens. And then if I move C to 2, guess what? This is what happens. And it's the same line again. See that? Now what happens if I move A to 3? That was another example. Okay, well that changes the line. If I just move the A, it changes the slope a little bit. If I move B to 3, it does that. Now they're parallel. Oops. And then if I move C to 3, they're the same line again. And that works for anything like negative 3.4, negative 3.4. Ish. There we go. And negative 3.4. See? So that's just showing you that if you multiply all of the terms by the same number, it's actually the same line. Cool, hey? I think that's cool. You guys might not think that's cool. I think that's cool. But anyways, we need to understand that that's true for elimination, right? Okay, so this whole second idea is for the substitution and elimination. Okay, we need to understand that. We can also create an equivalent system by adding or subtracting terms to both sides of the equation. That's true too. Okay, finally, the last big topic here is that a system of two equations may have one solution, an infinite number of solutions, or no solution. This is what we did just yesterday in 7.6, right? So how do we do that? Well, if you're looking at the graphs, it's easy. If you find that the graphs have different slopes and there's an intersection point, that's the one and only solution to the system. Okay, that's most cases. If you see that there's two lines that are parallel to each other and they have the same slope and different intercepts, then there's no solution. So this is one solution. This is no solutions. And finally, if they are the exact same line, then they have an infinite number of solutions. Okay? And we will actually do the algebra practice and identifying slopes and intercepts a bit later. Okay? But those are the three big ones. Okay? Any questions there? This is review, so you might be like, yeah, I know all this. If that's the case, then that's great. Everybody good?
Yes, sir.
Any clarifying questions? No? Okay. All right, we're going to practice this in a bit. Okay, so let's actually practice this now. In your review question, let's see, I think I'm on the wrong one. Let's go back here to this one. So in your review assignment, this is number 1 in your review assignment, and I thought I would do this one. My internship many, many years ago, when I was in my final year of education, you have to do a semester internship, right? We had interns before Christmas, right? Remember that? So I did my internship at Bedford Road. Shout out to Bedford Road, okay? And I was there during the Brit tournament, and it was really cool. It was like the whole school was like crazy, and it was pretty awesome. So anyways, so this question mentions the Brit tournament. So anyways, let's see. In section 7.1, you have to make up a system. So you have to read the word problem, and you have to make up 2 equations out of this information. So let's read it and see if we can identify information for 2 equations. 2009 Bedford Road Invitational Tournament held its 41st annual basketball tournament. Okay, so that means it's been going for 41 years up to this point. All right, so there was 41 years of the tournament. Now let's keep reading. Teams from outside Saskatchewan have won the tournament 17 more times than teams from Saskatchewan. Okay, all right, so that's cool. So here's the information for 2 equations. Now, first thing we want to do is we want to say, what are the things we're asking to find? So it doesn't ask you a question here, but the question that would be asked in this situation is, how many times have teams outside the province won, and how many times have teams inside the province won? So we're going to let O be teams from outside Sask. Okay? And let's let S be teams from Sask. Okay? Because those are the 2 things that we're talking about here. So the question is, how many times have teams from Saskatchewan won and teams from outside Sask won? So does anyone have any idea what the first equation might be with this blue information there? Is there a hand over there? Go ahead and shout it out if you want.
O plus S equals 41.
Yes, very good. O plus S equals 41. There's been 41 tournaments, so there's been 41 champions. Make sense? And all the champions either come from inside Saskatchewan or outside Saskatchewan. So O plus S, the number of times outside Saskatchewan teams have won, plus the number of times that inside Saskatchewan teams have won, have to equal 41. All right. Now, what about the yellow group of information? What's the second equation we should make there?
O equals S plus 17.
O equals S plus 17. Okay? I like it. There's other ways you could write that, right? It's a difference of 17. So I like the plus. As you remember, it's always good to have a plus instead of a minus, but so outside Sask has won more times. So that would equal the Sask teams plus 17. And that's exactly what you said, right? Yeah. That's awesome. Okay? So you could do it other ways. You could do O minus 17 equals S. You could do O minus S equals 17. Those 3 are all fine. Okay? Okay, so that's great. We can solve this pretty quickly. Let's solve this by substitution. Okay? Let's solve this. So substitution. I see that I already have O isolated. So guess what? This expression for O is going to go in for O in the other equation. So I'm going to have S plus 17 in for this O plus S equals 41. Okay? You guys see how that's a good choice for substitution there? Yes? All right. So this is 2S plus 17 is 41. 2S equals, what's 41 minus 17? 24.
Yes.
S equals 12. When you divide both sides by 2. Okay, so if S equals 12, let's find out what O is. Well, that's going to be 12 plus 17 from the second equation, right? So O is 29. So you would finish with a word sentence. Teams, and I'm going to write really messy, but teams from inside Sask won 12 times, and then blah, 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 teams from outside Sask won 29 times, okay? So a word sentence of some sort would be appropriate for a word problem. Okay, so that's creating, that's a little bit of both. That's creating a linear system, 2 equations, and then we've just practiced substitution. Okay? All right, here's another example. I'm just looking at the time. Let's do this one real quick. We won't solve it though, okay? If you were asked to create a linear system with this one, let's just do this again real quick. Yvette operates a snowblowing business. She charges $15 for a small driveway, $25 for a large driveway. One weekend, Yvette made $475. Okay, so this is all money. So I'll highlight those in the same. And then clearing the snow from 25 total driveways. Okay, so the driveways that she's snow blowing are small and large. And so how many are we talking about in this question? The total is? 25. Yeah, very good. Now the money one, 15 for every small. So guess what? I'll just go 15S plus 25 for every large. Good. And that equals 475. Any questions about that?
Wait, for the first one?
Yep.
Why would it be 25?
Well, she's clearing snow from a total of 25 driveways.
Oh,
And that would come from the small driveways or the large driveways. So small driveways, so S, I didn't write this down, but S is the number of small driveways. L is the number of large driveways.
I thought it was 25, like the price for the...
No, the price is this one. She cleared snow from a total of 25 driveways. So there's no dollar sign there or anything, so that's like a total number of. That make sense now?
Yeah.
Yep. Cool. Anybody else have any questions? Good? All right. All right, we've got two more things to do here. So 7.1 was creating systems. 7.2 and 3, solving by graphing. This one should go pretty quick since we kind of covered this already. But if you have a linear system that looks like this one on the right, and you have two lines that seem to intersect, that intersection point is the key to the solution. Now remember, I'm pretty strict with this. The solution is not this point. You cannot just circle that as a solution to the system. Why? Because the system, the unknown values are X values and Y values, right? So I need to know X is this, Y is this. That's how you need to write it. Now it's pretty obvious. You could figure this out that X is -2 and Y is 1, but you have to determine that. Because what happens if this wasn't X, this was C, and this wasn't Y, this was L, okay? You could write the C on the bottom and the L on the side, or you could opposite, so this doesn't tell me which one's which in that case, right? So this is pretty important to say, in this case, X is right here, -2, and Y is 1, because that's what the intersection point tells you. Okay? The coordinates are the solution of the linear system, but you have to state which is which. Verify, okay, you could substitute these values into both equations, check if they're true. All right, from the graph, good? Intersection point, make sure you write your solutions, including the variables. Okay, elimination and substitution, we need to talk a little bit about those two. So here's an example. It's already stated out here for you, so I'll just kind of highlight it. If you have a linear system and you're asked to use elimination, what you want to do is you want to focus on getting, remember, one of the coefficients of one of the variables to be the opposite of the coefficient of the same variable in the other equation. So the two y's here, this is -1 and +1. If you have that, you can simply add the equations together, and this will eliminate the y variable. Now if the system was this, -5 and then +5, still awesome. You add them together and the y's terms are gone, right? So as long as you have the opposite coefficients, same number, opposite sign. You add them up and you can solve for one variable, you substitute that variable into one of the equations to find the other one. And you check them and then you circle the answers. Okay? So elimination is adding equations to eliminate one of the variables, and you will eliminate your variable if the coefficients on the same variable term in both equations are opposite. Substitution, okay, substitution for this one is going to require a couple more steps, but it shouldn't be a big deal. I'm going to take this second equation and I'm going to isolate for y. -4x minus 7 by getting this 4x to the other side. Now that I've done that, I can substitute what y equals here in for y in the other one. So I'll do that for you. Minus, please be careful with your signs. We have a minus and we have negatives in here. So use your brackets, make sure you have your signs sorted out. So this is 2x, this is a plus 4x, and this is a plus 7. Everyone see that? When you distribute that negative sign. So this becomes 6x, and I'm going to subtract 7 from both sides. So that's negative 5 minus 7 is negative 12. You divide both sides by 6, you get x equals negative 2, which is what we got there. Substitute back in, you get y, you should get y equals 1. Okay? So again, that's just a quick run through for the substitution. All right, questions about substitution or elimination methods there? Any questions? Good? All right. Thank you for being so attentive and listening so carefully. I appreciate that. We're almost done. Okay? So the last one, let us actually get some practice with determining, okay, the number of solutions. Graphically, we already talked about this, what they look like. We already know that. So once again, what we have to do is determine whether the slopes of the lines are the same. So if the lines are different, then there's exactly one solution. It doesn't matter what the y-intercept is, it doesn't matter. If the slopes are different, you have one solution. For option number 3 here, the infinite number of solutions, if you have the same slope and the same y-intercept, so same slope and same y-intercept, then both lines are going to coincide and they will have an infinite number of solutions. The second one, if it's the same slope but a different y-intercept, then there's no solution. That means they're parallel. Okay? So there's 2 ways that you could check. The best way is to rewrite each equation into y equals mx plus b, because you can see the m and you can see the b, right? That's going to be your best way to do it. That's what I would suggest. I am going to show you a shortcut in a second to find the slope. Okay? So for this first, I guess they're both the same. So let's check this one and see what happens. Whoops, I want to zoom in a bit. So let's check this system right here. And I'm going to get y to be all by itself. So my first step is to subtract a 2x from both sides. And I'm going to divide by 4. So I have negative 1/2. That's 2 over 4. Plus 6 over 4 is 3 over 2. Okay. So when we, y equals mx plus b, it should be next there. That's what the first one looks like. The second one, 8y equals negative 4x plus 10. Y equals, when you divide by 8, you get negative 1/2 x plus 5 over 4. All right, so that's zoomed in quite a ways. I'm going to get back out here. All right, so what's the comparison? What do we see? We have the same what? Do we have the same slope? We have the same slope, but we have a different y-intercept, don't we? So same slope, different y-intercept. Which category is that one in? Yep. So how many solutions?
0.
None. That's right, 0 solutions. Okay. All right. So I'm going to show you a shortcut here now to find out from standard or general form. You can quickly find out the slope to see if the slopes are the same or different, and that's, I think, pretty helpful. Because if you can determine whether the slopes are different right away, then you know how many solutions there are. So remember, ax plus by equals c is the standard. And so if you do negative a value divided by the b value, then you will get the slope. So you don't have to change everything over into y equals mx plus b. You can find the slope just a little bit quicker All right, now you still don't know what the intercept is, so you should still be changing into y equals mx plus b form. But you can check the slope. So with this one right here, let's see if this works for this equation. So the slope for the first one is negative a, that's negative 2, divided by b, which is 4. Negative 1/2. That is true. That's what we found. The second one, negative a, that's negative 4 over here, divided by 8. And that's negative 1/2. So you see how this works? This would be a good one to jot down into your notes there. Yeah. Yeah. And for the record, you can, from standard form, find out what the intercept is, but it's different in general form, so I hesitate to give you kind of like a formula. All right? So this one works for either. All right, I think that's the end of my little review video here. So do any of you have any questions for clarification or anything that you still don't understand? No? Yes?
Could you show elimination with
Elimination for this one? Or for just an elimination example? Another?
example for elimination?
Sure. Let's do, let's do this one. Actually, no, let's do one that didn't we do one? I guess we kind of did this one, but that was an easy one, right? So let's do a harder elimination question. I think that's awesome. Yes. Oh, and actually, because there's no solutions, let's do the one where there's no solutions to, so I'll show you what that looks like. When you algebraically, yeah, that's a good idea. So if you are doing an algebraic, how about I talk? If you're doing algebraic method of elimination or substitution, and there's no solutions, what does that look like? So I will show you here right now. Because from the graph, they're parallel, but what does it look like when it is just the algebra? Okay. Yeah, so you can do this one with me. Let's do elimination here to solve. Okay. Okay, right now, it doesn't really matter which variable you to eliminate first. They're both easy. You have to multiply just one equation, right? So I'm looking at the x's first. Right now, they aren't opposite signs, so I have to multiply 1 by a negative, because they have to be opposite sign. And then 4 is a multiple of 2, so if I just multiply this equation by negative 2, do you see how I'm going to end up with a negative 4x here? So let's rewrite this down below. So this top equation becomes negative 4x minus 8y equals negative 12. Okay. Yeah. So let's add up these two equations here. So now these are the two equations I'm going to add up. This one's gone. All right, so what do I get when I add those up? Well, I get 0 plus 0 equals negative 2.
Oh, wait, what?
10 minus 12.
I wrote that wrong in my book.
Okay,
I see that.
so 0 equals negative 2. Now, there's a problem with this. If we had a variable here, then that's fine. If we had like a number, a variable somewhere in there left, but we have no variables. Instead, I have a number 0 equaling a number negative 2. Is that possible? So this is not possible. So if you get something like this, if that's not possible, then there are no solutions, because the math is telling you, hey, we have a problem here. This method is supposed to work if there's a solution. So this method does not work when it looks like this. If you have one number equaling another number, if that's what you get, then that can't happen. There's no solution. So what happens, okay, so that's that. Do you want to know what it looks like if there's an infinite number of solutions?
Yeah.
Okay, So if there's an infinite number of solutions, let's say this one was 12, okay, because that's what it is in the other example up above. So if that's the case, now look what happens. 12 minus 12, this would be the case where you would get something like this. Now, if you had 0 equals 0, or a number equaling itself, like 5 equals 5, or -7 equals -7, if you have that situation, then this is possible in any case. So this is always true. So in this case, it's always true. That means you have an infinite number of solutions. Okay? So just a hint, if you're doing the algebra methods of substitution or elimination and you solve for a variable, but the variables both disappear and one number equals itself, you have an infinite number of solutions. It's the same line. If you have a number equaling another number, a different one, then that can't happen. There's no solutions. Okay? So that's always true. Infinite number of solutions. Here's the other one. 0 equals -2. Never true. No solutions. Okay, so there's another elimination example, and then what happens if you run into these two things? This is what happens. Okay, does that help? Yeah? Okay, good. Yes?
What if it's a negative and a positive?
Doesn't matter. It doesn't matter. Yeah, if they're the same number, it's this one. If they're different numbers, like if it's a -2 equals +2. If there's no variables left, then you've got one of those situations where there's no solutions or infinite number. Yeah, if there's no variables left. Okay? Any other questions? Because I think that's all I wanted to tell you. That's the whole chapter. That was a long one. But that's very thorough, I think. I don't think we really missed anything. Good? All right. The review assignment was posted there earlier. I'll put that back up. But I'm still recording. So do you guys want to all shout goodbye?
Bye, love you. Have a great night. See you at Bedford Falls, or whatever it was.
Bedford Falls?
Yeah, your shout out.
Okay, so first of all, that was Bedford Road High School in Saskatoon. Bedford Falls is the town in It's a Wonderful Life. Merry Christmas, Mr. Potter!
Merry Christmas, Bedford Falls.
You guys know that movie? It's a great movie. Who? Shout out to who?
India.
To India? Who wants to shout out to India? Okay.